So let's fill in what I know. Sine. What did I say my amplitude was? What was my amplitude? 5, right? So my amplitude is 5. That doesn't really matter when you're drawing the graph. My k term I said was 30, right? 30. And 16 is the vertical shift. So I know that the 16 goes up here. Now with the horizontal shift, it's really important how we divide this graph, okay? So, 2 hours, 4 hours, 6 hours, 8 hours, 10 hours, 12. Okay, so if my graph is going to be every 12 hours, and my, I know that the sine function has going to have one, oh, let me think about this for a second. Let me think about this for 1 second, guys. Every 12 hours, one cycle is every twice. So that means one full cycle is over here, is at 12 should be over here. So if I look at my key points, 1, 2, 3, 4. So this is going to have one area. Up to here is another key area. And up to here is another key area. So that cycle, that from, let me highlight, from 11 back to 11 again, this is my full cycle, right? How many parts have I divided that full cycle into? How many parts? So this is 1, 2, 3, 4. 4 key parts for the sine function, because we go from our minimum to our axis of symmetry to our maximum, back to the axis of symmetry, back to the minimum. What was screwing me up before is I extended it back to the axis of symmetry, and that's more than one key cycle. That's why my calculations weren't working. So we have four key parts. What is 12, my period, divided by 4? What's my period divided by 4? 12 divided by 4 is 3. So that means that's how I should label my x-axis. 0, 3 hours. 3 plus 3 is 6 hours. 6 plus 3 is 9 hours. 9 plus 3 is 12 hours. So for a complete cycle to happen, we go from 0 to 12 hours. So everything is fine, vertical shift is fine, but now we have to talk about horizontal shift. Remember, this is the sine function. The sine function always starts at the axis of symmetry. Is my function starting at the axis of symmetry? No, because the axis of symmetry is along the line 16. So that means for it to be a true sine function, it has to start here at the axis of symmetry. That means not only has this sine function been shifted up by 16, but this sine function has also been shifted to the right. So my point that should be here, it's actually been shifted by 3 hours. Wherever your starting point, you always locate the starting point of the axis of symmetry. If my starting point had started here, then I know it's been shifted by 9 hours. If the starting point had started here, then I know it's been shifted by 6 hours. But wherever this starting point is, that should be your the number of hours that you put in your equation. So that means my final equation should be x minus 3, because this graph has been shifted to the right by 3 hours. So horizontal shift is always the most difficult part, okay? Just to draw a quick other sketch, if the graph had started like this and went like that, for example, I know that the graph would have to start here, so I would put the graph has been shifted to the right by 9 hours. Basically, you always locate your first point on your axis of symmetry, and that becomes your horizontal shift. Okay, so that is it for the seminar. I am going to do another word problem this word problem that's in your, that's similar to something in your unit guide for the pen cast part of the Unit 14 seminar. It's a Ferris wheel problem. But this is what Unit 14 looks like, a whole bunch of word problems. Anything that's round, so a tire, a Ferris wheel, tides, anything that has cyclical behavior, okay? Surprise! Unit 14. But I have my answer key with me at all times. So we're going to end this seminar, hopefully this recorded. I have seminar sheets, so those of you who need to rush off can just grab a seminar sheet and go along your way. But I'm going to keep that problem up on the board in case you want to copy it